So now another terms which is very important in our production process is the return to scale. What is return to scale? How we can define the returns to scale? This is the definition of different return to scale. What is the overall definition? Overall. Yeah. So this is the definition for constant return to scale, increasing return to scale, and decreasing return to scale. What is the definition for the own concepts of return to scale?
If the production function multiplies, if all factors of production multiplied by t,
yeah,
what happens?
Yeah. As he said, for example, when we multiplied all our input by some factor of t, which is this t is positive, like we multiplied L with some factor of t or scalar of t, and also we increase our capital. So then, what will happen to y? Or another way we can define return to scale, what does it mean? If we scale up all our input by some positive factor of t, what will happen to the output level? And there, three results can be possible, or three outcomes can be possible. By having three different outcomes, we have three different return to scale, which is constant return to scale, increasing return to scale, and decreasing return to scale. In the case of constant return to scale, if you scale up, this x is a vector, of input. It can be your labor and your capital. If you increase all input by some scalar of t, if your output increase exactly as the same amount of t, then we have constant return to scale. For example, if we have this function, f of L and k is equal to y. F of L and k is equal to y. Now, we are multiplying L with some positive scalar of t, TL, tk. And if it is equal to t multiplied by f of k and L, and already we know that f of k and L is equal to y. F of k and L is equal to y. Then instead of f of k and L, we can simply write down y. Y is our output. When we increase the input by some scalar of or some amount of or some factor of t, if our output increase exactly by the same level of t, it's constant return to scale. Or in numerical way, for example, if we double our input, if t is equal to 2, if t is equal to 2, if we double our input, if our production is also doubled, then it's constant return to scale. In the case of increasing return to scale, if we increase all our input, for example, labor and capital, if the new output that we bring is greater than, is increasing by more than t, then we will have increasing return to scale. Like for this one, we have our y as a function of labor and capital. Now, we are scaling up labor and capital by some amount of t. Then f of TL and tk. and the output that we get from this combination, if it is greater than if we multiply t to the f of kl, then it's increasing return to scale. And we know that f of kl is equal to our y. Then if this one is greater than this combination, f of tl, tk is greater than t of y. T of y. But here it was equal to ty, but here is greater than ty. That means we are doubling our input, but our output increased by more than double. But our output increased by more than double. So it's increasing return to scale. But in case of decreasing return to scale, if we scale up all input, but the new output that we get from the scaling gap is less than t multiplied by f of x. That means intuitively, when we are doubling our input, but our output increased, but by less than double. Our output increased by less than double. For example, when the t is equal to 2, the y prime, which is your new output, is somehow 1.5 of your previous output. Increased, but not as equal to as t, but less than t. So it's decreasing return to scale. But when it comes to like real companies, firms, they have different utility, different return to scale, and different production like location. For example, in the beginning, they have increasing return to scale. When a company tries to enter to the market, like they may show some this kind of curve. Which is in this area, we have increasing return to scale. In this area, like for example, is something linear. We have constant return to scale. And finally, we may have decreasing return to scale. It depends on which location you're in now. So we cannot say that a company is always located in decreasing, increasing, or constant. It depends on where you are. But mostly in our analysis, when it comes to like class, studying microeconomics, we are thinking about this one. Most of our production function that we use is constant return to scale. That's why when we are writing the Cobb-Douglas production function, we write y like x1 to the power of alpha, x2 to the power of 1 minus alpha. x2 to the power of 1 minus alpha. So in another definition, we can say a technology exhibits a constant return to scale if and only if the production function fx is homogeneous of degree 1. Is homogeneous of degree 1. How? For example, if f of tx f of tx is equal to t to the power of k f of x. By using this equality, we can define the homogeneous of degree. So a function of f of x is a homogeneous of degree k F, the f of tx is equal to t to the power of k multiplied by f of x. So then, if the k is equal to 1, it's called its homogeneous of degree 1. If the k is greater than 1, it's called homogeneous of degree like greater than 1. If k is less than 1, it's called homogeneous of degree less than 1. But in case of constant return to scale, a function is a constant return to scale if this k is equal to 1. It means it's a homogeneous of degree 1. But in case of decreasing and increasing return to scale, especially in case of decreasing return to scale, that the k, or in other ways, alpha, should be less than 1, which is in this case, homogeneous of degree less than 1. For the increasing return to scale, that alpha, or as we notified here as a k, should be greater than 1. That means it should be homogeneous of degree greater than 1. So let me give you a production function. For example, if we have k equal to x1 to the power of 0.5 multiplied by x2 to the power of 0.7. What kind of return to scale this production function will show? Do you think it's constant return to scale, increasing return to scale, or decreasing return to scale? Decreasing? In order to know that what kind of return to scale this function shows, we need to find out the homogeneous of degree. If it's 1, less than 1, or more than 1. Then we can say that its return to scale is constant, increasing, or decreasing. For this case, as we already said, that if f of tx is equal to t to the power of k multiplied by f of x. So here, f of tx is equal to this one. So then we multiplied, like in this case, t multiplied by y is equal to tx1 to the power of 0.5 multiplied by tx2 to the power of 0.7, tx2 to the power of 0.7, tx1 to the power of 0.5. It can be equal to, so we have t as a common factor. Then t to the power of 0.5 plus 0.7 multiplied by x to the power of 0.5, x2 to the power of 0.7. And it's equal to t to the power of 0.5 plus 0.7, 1.2 multiplied by x1 to the power of 0.5, x2 to the power of 0.7. Now our k is equal to 1.2. So then, when this one is a homogeneous of degree more than 1, then what type of production function it be? It should be increasing return to scale. But in the case of like when we are talking about profit maximization, mostly we use this kind of Cobb-Douglas production function, which is x1 to the power of, for example, 0.3, x2, 0.7. x2, 0.7. And in general case, x1 to the power of alpha, x2 to the power of beta. For the Cobb-Douglas utility production function, there's an easy way to conclude that either this Cobb-Douglas production function shows increasing return to scale, decreasing, or constant return to scale. So let's work for that one. So if we multiply t x1 whole to the power of alpha then t x2 whole to the power of beta. Then we can write down t to the power of alpha plus beta multiplied by x1 to the power of alpha, x2 to the power of 1 minus alpha. And we know that this part is exactly equal to our y. But only here we have this one, t to the power of alpha plus beta. So we can write down t to the power of alpha plus beta multiplied by y. So now in order to conclude that either this Cobb-Douglas production function shows what kind of return to scale, this one is very important, alpha plus beta. Because this alpha plus beta shows the homogeneous of degree. As we know from the definition, when alpha plus beta is equal to 1, then it's constant return to scale. If alpha plus beta is greater than 1, then it's increasing return to scale. In the other case, if alpha plus beta is less than 1, then it's decreasing return to scale. So now if you have a Cobb-Douglas type production function, if someone asks you that what kind of return to scale this production function shows, just sum up these two. In this case, which is equal to 1, so it means this Cobb-Douglas production function is constant return to scale. If this is greater than 1, increasing return to scale. If it's less than 1, it's decreasing return to scale. The easiest way to find out that either in Cobb-Douglas production function is increasing, decreasing, or like increasing.